Okay, so we are going to look at ratios. What is a ratio? A ratio is a really useful way of being able to compare different quantities and amounts for different things. A very simple example here would be that we have 2 triangles and 3 rectangles in this picture. So we could express that as a ratio, and a ratio is expressed in a very specific way. We have the 2 and the 3, the 2 representing the 2 triangles, and then the 2 dots, and then the 3. And that tells us it's a ratio. For every 2 triangles, there are 3 rectangles. That's the way that we want to look at that. Okay. We can also turn that round the other way and say that the ratio of rectangles to triangles is 3 to 2. So for every 3 rectangles, there's 2 triangles. What we need to be able to do is work with ratios. So we can simplify ratios, and to simplify ratios, we use the same process that we use when we simplify fractions. In other words, we have to think about finding a highest common factor. The biggest number that you can divide both sides of the ratio by, the biggest number that goes into, for instance, this first one, 6 and 8. So the biggest number that 6 and 8 can both be divided by is 2. So if we divide each side by 2, we get 6 divided by 2, which is 3, and 8 divided by 2, which is 4. Okay, and then for 12 and 28, our highest common factor there, the biggest number that goes into both 12 and 28 is 4. Okay, so the 4 times table, in other words, has 12 in it, and it also has 28 in it. But that's the biggest number. 2 is also a factor of both 12 and 28, but it's not the biggest, it's not the highest common factor. So we want to get the biggest number that goes into both 12 and 28. So we can divide both sides by 4, and we get 3 to 7 as our simplified ratio. Okay, another few examples of these, 52 and 4. 4 again is our highest common factor, so dividing both sides by 4, we get 13 to 1. 80 and 25, well, that's going to be 5 is the biggest number that goes into both 80 and 25. So 80 divided by 5 is 16, 25 divided by 5 is 5. And 72 and 20, a little bit trickier here, but you just got to work through to various numbers to start with the 20, or the factors of 20, and see which of those are also a factor of 72, and it's 4. So 72 divided by 4 is 18, 20 divided by 4 is 5. So that's our simplified ratios. So they are important, simplified ratios. We use them for various different things. It's to be able to just take something that's a little bit trickier looking and express it in that simplest term. The other thing that we can do with ratios is ratio calculations. So for ratio calculations, we can use these to work out missing values or to estimate missing values, and we're going to use a table to solve problems for these. Okay, so let's look at an example. The ratio of boys to girls is 2 to 3. If there are 12 boys, how many girls are there? So this is using our ratio. Our ratio in its simplest form is for every 2 boys, there are 3 girls. So we want to then take that and say, well, actually, we don't just have 2 boys, we've got 12 boys. So how many girls must there be? The easiest way to do this, most straightforward way to do this, is to set up a table. So our table, at the top we've got boys and girls, because that's what our example has given us, and for every 2 boys there's 3 girls, so we'll put that under each of those. And then the other bit of information that we know is that there are 12 boys, so the 12 is going to go in the boys column, and we need to work out the missing bit of information, the corresponding girls for that. Now, the way that we're going to do that is think about, rather than simplifying, where we divided, we're going to multiply. It's how we got from 2 boys up to 12 boys, and how many times 2 goes into 12. is 6. So we would multiply 2 by 6 to get 12. So we'll do exactly the same on the other side. 3 times 6 is 18. So that tells us there are 18 girls. Another example, ratio of cars to buses is 5 to 2. If there are 24 buses, how many cars are there? So we're going to set this up in exactly the same way with our table, except this time it's going to be cars and buses. Okay, and cars are 5 cars and 2 buses. So the 5 and the 2 will go in our table. And then we're told that there are 24 buses. So the 24 is going to go under the 2 in the buses column, because that's what we've been told, which means we're missing the cars. So we do the same thing again, except it's just on this other side. It's how many times 2 goes into 24. We would multiply by 12 to go from 2 to 24. So we'll do exactly the same on the other side. We'll do 5 times 12, which is 60. So there are 60 cars. Okay, so that's how we use ratios to work out missing bits of information. The other way to use ratios is where we want to share in a ratio. So rather than just where we're taking one quantity, one amount, and splitting it, but splitting it in a certain way, in a certain ratio. Okay, so if we look at an example of what we mean by this, is the easiest way to think about this. So we've got Cara and Rebecca sharing a raffle prize of £420, but they're sharing it in a ratio of 3 to 4. So how much will each receive? So we've got to work out this £420 is the full amount, and it's been shared between 2 people, but we're not just equally, they're not getting equal shares. They're getting, Cara's having 3 of the shares and Rebecca's having 4 of the shares of the £420. So we've got to work out how much each person gets. And the way we do that is thinking about how many shares are there in total. If it's a ratio of 3 to 4, then there are 7 shares in total. So we add our ratio to get our 7 shares, which means we can work out how much 1 share is. So we take our £420 and we divide it by 7 to get £60. And then this £60 is 1 share. Cara has 3 of those and Rebecca has 4 of those. So 3 shares is 3 times £60, which is £180 for Cara. And 4 shares is 4 times £60, which is £240 for Rebecca. And we can check this. The total, that 420 should still be the total. So 180 plus 240 does make 420. So that is our money, that's our prize shared, not equally, but completely between the 2. Okay. So let's look at another example of that. Now this time we've got a ratio, £24,000 to be shared in the ratio 1 to 2 to 5. Now we can have ratios like this where we've got 3 different quantities. So 1 share to 2 share to 5 shares. And it works in exactly the same way, in that the total amount of shares is we find by adding the separate parts. Okay, so 1 plus 2 plus 5 is 8 shares altogether. So the £24,000 we can divide by our 8 to get £3,000 for 1 share. And then we just apply that 1 share across each ratio. So 1 share, our 1 was the 1 times 3,000, which is still 3,000. 2 shares for the 2 part of the ratio is 2 times 3,000, which is 6,000. And 5 shares is our 5 times 3,000, which is 15,000. So, and again, we can check that those all add up to our £24,000, which they do.